The cross product basically gives us a vector that is orthogonal or perpendicular to two given vectors in the 3D world. So let's dive right into it with an example. We have an example that says find the cross product of vector u and v when u is 2i plus 3j plus 3k, or correction, 2i plus j plus 3k, and v is I plus 3j plus 2k. So the way we find the cross product is we use the determinant of a matrix. So on the top row, we're always going to have I, j, and k. In the next row, we're going to put vector u because u comes first. So we're going to put the coefficients of I, j, and k. If it was in component form, we would just put the numbers. We have 2, 1, and 3. And then we put the second vector, which is in this case vector v, which is going to be 1, 3, and 2. And we take the determinant of that particular matrix. So I'm going to use the cofactor method for finding determinants. So I'm first going to pick a row, so I in this case, and we're going to block out the column and the row that I is in. So we're going to be left with the determinant of 1, 3, 3, 2. We're going to have negative j, then block out that, so 2, 1, 3, 2. And then positive k, 2, 1, 1, 3. Okay, so that's going to be 2 minus 9, which is going to be negative 7i. And it's going to be 4 minus 3, which is going to be 1, negative 1, minus j. 2 times 3, 6 minus 1, which is 5k. Okay, so that's going to be the cross product of u and v. Now let's find the opposite, the cross product of v and u. So we're going to have, again, I, j, k. We're going to have vector v first, so 1, 3, 2, and then 2, 1, 3. Again, using cofactors I, 3, 2, 1, 3, minus j, 1, 2, 2, 3, positive k, 1, 3, 2, 1. And we're going to have 9 minus 2, which is 7i, 3 minus 4, negative 1. Negative and negative is positive, so positive j, and then 1 minus 6, which is going to be negative 5k. And as you can see, they're actually very, very similar. They're just pretty much the same vector, but they go in opposite directions. So when you take the cross product of v and u, and then you take the cross product of u and v, you get two vectors that basically go in opposite directions. Okay, so now looking at a couple of properties of the cross product, of what we can use the cross product for. So if vector u and vector v are parallel, the cross product of u and v is going to be equal to 0. If we have a parallelogram and we want to find the area of it using vectors, we're basically going to find the magnitude of the cross product of u and v, and that is if u and v are adjacent sides of that parallelogram. So adjacent sides of the parallelogram. Okay, so if you want to find the angle between two vectors, what we have is we have the sine of that angle is equal to the magnitude of the cross product of u and v divided by the magnitude of the individual vectors. And this is actually very similar to one of our other properties of just plain 3D vectors. So make sure you don't get confused to that. That also involves the cosine of theta is equal to the dot product over the magnitudes. So don't get confused with that. That's a different property. If we want to find the angle between two vectors, the sine of that angle is going to be equal to the magnitude of the cross products over the magnitude of the individual vectors. Now let's take a look at the triple scalar product. Basically, the triple scalar product is a numeric value, not another vector, where it's the dot product of u and the cross product of v and vector w. And what we can use this for is to find the volume of a parallelepiped, which has basically it's a prism kind of solid, and we were given three different vectors corresponding to adjacent sides. And what we're going to do is we're going to take the triple scalar product of these three vectors to find the volume of this parallelepiped. So what we'll do is we'll just find the determinant again, and instead of filling in ijk for the top, just like for the cross product, we're going to fill in these three vectors as our three rows over here. So first, vector u, 1, 1, 1, vector v, 0, 3, 3, and then vector w, 3, 0, 3. Alright, so now using our cofactor method, we have a 0 here. So if we take this particular column for using our cofactor method, since there's 0, 0 times anything is going to be 0. So all we have to worry about is this one and this one. So let's do that. It's going to be 1 times the determinant of 3, 3, 0, 3. We can ignore the 0 and over to 3. 3 times the value of 1, 3, 1, 3. Okay, so now 1 times anything is that anything. So 9 minus 0 is going to be 9. And then 3 minus 3 is going to be equal to 0. 0 times anything is 0. So we have 9 units cubed. Make sure to put our units, and since there's no unit specified, it's going to be just units cubed because it is the volume of a parallelepiped.